Hello everyone, welcome to Gangs of PCM. This is Priyanshu and together we are going to solve all your physics related worries. Today we are going to discuss a question from JEE Mains exam which was held in January of 2020. This question is from chapter Atoms, and to solve this question we need to know the formula for radius and velocity of electron in nth orbit of hydrogen. Now, according to Bohr's first postulate, we know that the electron which is orbiting around an atom, which is orbiting around a proton in an atom, the radius of the atom, let's suppose it is Rn, and the velocity with which the electron is rotating, let's say it is Vn. Now we know that from this law, or from the first postulate of Bohr, it says that the electron revolve around the proton in a UCM, that is uniform circular motion. Okay, that means the speed is constant. The centripetal force is provided by Coulomb's force, or you can say your mv square by r, which is your centripetal force, is equal to the Coulomb's force between the protons and the electrons, which would be 1 by 4 pi epsilon naught q1 q2 upon r square, or in this case we can say your mv square by r is equals to 1 by 4 pi epsilon naught e square by r square. Okay, using this formula as well as the formula from the Bohr's second postulate, which says that angular momentum of any electron in an orbit is equals to nh by 2 pi, or integral multiple of h by 2 pi. Using these two formulas, we get the formula for radius and velocity of the electron, which is given as the following. The radius of nth orbit is given as Rn is equals to epsilon naught h square divided by pi m square e square into n square, where epsilon naught is permittivity of free space, h is Planck's constant, your pi is your pi 3.14, m is mass of electron, and E is fundamental charge. We also have N. Which is N? N is the nth orbit, also known as or principal quantum number. Principal quantum number. This tells you the number of cells or numberth of the cell in which the electron is revolving. So this is your radius of electron. So from here we get what? All these things, permittivity, Planck's constant, mass of the electron, charge on the electron, all of these things are constant. So if we put it like this, we can say radius of electron in nth, or radius of the orbit in or radius of the nth orbit of hydrogen is proportional to its square of principal quantum number. Similarly, we get the velocity of electron in nth orbit. This is given as Vn is equals to E square divided by 2 epsilon naught h into 1 by m. Again, E is your charge. So E is your charge. Epsilon naught your permittivity of free constant, permittivity of free space, and h is your Planck's constant. So from here we get velocity of electron in nth orbit is proportional to, or inversely proportional to, principal quantum number. Okay, so these two are the velocities of, or this is the velocity of the electron, and whereas this is the radius of the electron. Now let's go back to the question. Question asks what? Question says that time period of revolution of electron in its ground state of hydrogen atom is 1.6 into 10 to the power minus 19, and the frequency of revolution of the electron in the first excited state we have to find out. So We know that, what do we know? We know that ground state is your n equals to 1, and first excited state is your n is equals to 2. Okay, so ground state and the first excited state, n equals to 1 and n equals to 2. Now, time period. The time period is for particle performing UCM, it is 2 pi r by v, where r is the radius of the particle in which it is performing circular motion, uniform circular motion, and v is the velocity of that particle. Now here, so from here we can say t is proportional to r and t is inversely proportional to v. Okay, so from here if you put the relationships of r and v, what I'll get? I'll get t is proportional to n square for r and t is proportional to 1 upon 1 by n for v. If we combine these two, what do we get from here? That t is proportional to n square divided by 1 by n. From here, what do we get? We'll have from here this t is proportional to n cube. Now, what does question say? For n equals to 1, let's say time period is t1, and for n equals to 2, time period is n2. This would be what? You'll have n1 square, or n1 cube, sorry, divided by n2 cube, which is equals to what? 1 upon 2 cube or 1 upon 8. Now, T1 is given to us. This is time period of the electron in the ground state, which is how much? If you go back to the question, which is 1.6, again 1.6 into 10 to the power minus 16. 1.6 into 10 to the power minus 16 seconds. This is the time period. So from here we'll get T2 as how much? T2 would be 8 times T1. So T2 is 8 into 1.6 into 10 to the power minus 16. Okay. Now we don't need T2. What do we need is your frequency. The nu2 is 1 by T2, which is equals to 1 upon 8 into 1.6 into 10 to the power minus 16. If we solve this, we'll get nu2 as nu2 equals to 7.8 into 10 to the power 14 hertz. Now if we look at the formula, we'll see that C option is correct. Okay, so the correct answer is C. Now I hope that everyone was able to learn something from this video. And if you're learning something from our video, from our efforts, keep coming back, and I promise you that we'll provide you quality content and you will always be able to learn something from us. Okay, so that's it for today. Bye bye. Thank you.